Working with Angular, we often have to deal with services that require an explicit initialization phase. Sometimes this logic might be located inside the service constructor, and sometimes it is a public method that needs to be called immediately after service instantiation. There is nothing wrong with this service design. However, instantiating such a service might be quite tricky sometimes. Later in this video you will learn what pitfalls you might encounter providing such services, how does provideEnvironmentInitializer fit this story, which patterns can be built on top of this Angular feature, and how different it from AppInitializer. For example, let's take a look at this tab visibility monitor service. This service contains initialization logic in its constructor, and it sets up a visibility change event listener to track when user leaves the application's browser tab and returns back. Now let's open our application and try to see if it is working. So I switch to another tab. Then I go back and see nothing inside the console. This is because my service has not been instantiated. But why? The reason is that the service wasn't injected anywhere in my application. Some of you might say, wait a minute, but you have provided in root configured. Shouldn't it provide the instance of the service to the application root injector? Exactly. But provideInRoot instructs Angular where the service instance has to be created, but not when. In fact, service creation happens at the moment of the first injection. So to fix my issue, I have to inject my service somewhere in my application. And very often the AppComponent is choosing in order to initialize such global services. So we could do it there as well. And now, if we try to switch between tabs, you can see that things are working as expected. And I think you can spot the issue here immediately, because to make things work, we have to create what I call a dummy injection, which is very fragile construction actually, and it is only a matter of time before some of your colleagues will try to remove this unused injection and potentially break your application. Of course, we can easily fix this issue by simply adding a short comment to not remove this line. Of course, if you have access to the source code of the service, you can always redesign it, and instead of running initialization logic inside the constructor, you can do it inside a dedicated method. This helps you to avoid the dummy injection, and things look, in this case, well, better, let's say. But this might be acceptable if the lifecycle of your service is tightly coupled with the lifecycle of the component. However, in my case, this service has nothing to do with this particular component and the view layer itself. So initialization of this service inside the component looks a little bit out of place, I would say. Additionally, if you write unit tests for this component, you would need to mock this service, and it will be additional inconvenience, especially if you have many such services to initialize. So what other options do we have? It is much better to perform such service initialization logic upon construction of the corresponding environment rather than a component. And we can hook into the moment of environment creation by providing a special function called provideEnvironmentInitializer, which can be included into the provider array for any environment injector you need. So you can think of it as a ngOnInit lifecycle hook for the environment injector. For example, providing it inside the appconfig.ts file will allow you to perform certain actions once the root environment injector is constructed, which happens right before the application bootstrapping process is started. So if you save this change right now and try to switch between browser tabs, you can see that everything continues working. And if you have to deal with the service where initialization logic happens inside the service constructor, it would also work just fine, with the only difference being that you don't need to call the init method anymore. And as I already said, you are not limited only by the root environment injector. It works with any environment injector, for example, the one created for the activated root. And for this example, I prepared another service that pulls data with certain time interval, and it also requires explicit configuration and initialization by calling the start method. So let's try to provide this service and initialize the data polling when the user navigates to the user's page. To achieve that, I have to navigate to the corresponding router config, and here I'm going to provide the data polling service itself because I want to create a dedicated instance of this service in the user's root environment injector and not for the application global injector. And then again, I use the environment initializer where I have to first inject the data polling service I provided, and then I can configure it and define maybe a scope of what should be polled, which exactly data I'm interested in, and eventually I can start the polling itself. So let's save this change and try it out. And you can see that the polling isn't started immediately because I'm currently on the homepage of my application. But once I navigate to the user's page, you can see that the polling is started and everything works as I expect. So it works great. However, if you need to configure the polling for some other routes, it would be pretty inconvenient because you would need to repeat all this setup again and again, while the only part that really changes is the configuration of the polling scope. To solve this issue with standalone API, we've got another pattern for that. And this pattern is represented by a simple function that might take certain arguments like configuration, object, etc., and then it returns an array of required providers for this feature that are configured based on these settings from the function arguments. So just like that. And very often such providers are guarded by the makeEnvironmentProviders function that prevents them to be used at the component providers level, right? But if you have to use it or not, it depends on your design and your particular use case. Let's say I want to use it for environment injectors only, so I will leave this guard here. So in this setup, in this pattern, the environment initializer works like ngOnInit hook for the feature provider. So others who will be reusing my polling feature, they would simply need to call this function with the proper config and not bother with explicit service initialization logic and other things. This pattern is actually widely used, and you might encounter it in many popular Angular libraries and also inside Angular source code itself. For example, this pattern is used for Angular router to enable the debug tracing feature. Here, the environment initializer is used inside the corresponding provider function to start listening to the router events to console log a fancy representation of router events. Another example of the environment initializer usage is how the global data store is initialized in the NGRX library. There, it is used to instantiate all necessary root store services which contain their initialization logic in their constructors. And then it is used as part of the provide store function that performs the entire global store setup. Basically, it works for any use case when your service needs to be initialized by running a dedicated method or when the initialization logic happens inside the service constructor. If you have some other use cases in mind, please share them with us in the comments below. If you have worked with Angular for a while, you might have encountered also AppInitializer, and you might be curious about the difference. Well, despite the naming similarity, those two are quite different things. The AppInitializer, it is a hook into the application bootstrapping process, when the Environment Initializer, it is a hook that is executed when the environment injector is created. Because of that, AppInitializer can be provided only for the root environment injector, when the Environment Initializer can be provided for any environment injector on every level. If you return observable or promise from the AppInitializer, it blocks the application bootstrapping process until the promise or observable is resolved, while the Environment Initializer doesn't block anything. And the last but not least is that Environment Initializer is called before the AppInitializer. So the AppInitializer is a perfect choice when you want to postpone the application bootstrapping until certain critical data is resolved, for example, the application config. The Environment Initializer is good choice if you have to perform certain logic once the corresponding environment injector is created. If you want to learn more about AppInitializer and how it works, I have a dedicated video about that. This video is pretty old but still relevant. The only thing that has changed is that the AppInitializer that I covered in that video was deprecated in favor of the provideEnvironmentInitializer function. The rest remains the same. This is Environment Initializer in action, and I hope you found this video useful. If you particularly like what I'm doing and you would like to support release of the upcoming videos, you can become a YouTube channel member, and in such a way you can unlock some additional benefits like early access to my content. You can get access to exclusive in-depth Angular tutorials and also extended coupons for my Angular courses. Alternatively, the easiest and free way to support my work, my channel, is to take the link to this video, to exactly this video, and share it with your colleagues and friends who also want to learn more about Angular. And of course, your comments, your subscriptions and likes are always appreciated. Otherwise, thank you so much for watching this video until the end. Stay safe and see you in the next video.